I did try to record second period, and again, it didn't work, so that's why I'm trying again fourth period. Okay, now if something is odd, then let's write this down. That means it's symmetric about the origin. Remember, origin is the center of a graph, 0, 0. And then if it's neither, that means it's neither one of those things. So instead of doing all the math that we did on our video notes, why don't we just graph this, okay, and then see what the picture looks like. So go grab your calculator if you haven't grabbed your calculator yet. Go turn them on, fire up these babies. Yes, Hudson?
So, I think that, can't you just say that it's, because it has the plus that the, wait, why am I looking for that?
Because it's not on.
Never mind.
Okay. So go clear your memories because I don't know what the zooming thing would be like left over with. So let's just clear everything. 2 plus 7, 1, 2. Go to the y equals and plot this picture, 5x squared plus 2. So go to y equals, type in 5x squared plus 2, and let's see what it looks like. So I'm not showing any work because I'm not doing it the mathematical way. So the way you can show your work for this from now on is just sketch out the picture. I don't even need the dots because it's just a sketch. It basically just looks like that. So I'm just sketching it out. Okay, so let's see if this picture is symmetric about the y-axis or symmetric about the origin or none of the above. Symmetric about the y-axis means that if I were to fold my picture on the y-axis, because symmetrical means like it's even on both sides, right? If I fold it on the y-axis, would the left side cover the right side? Like, would it be? Yes, it's a mirror image, right? So yeah, if it is, then it's even. And so in this picture, it's even. It's not symmetric about the origin. And let me show you what symmetric about the origin would look like. Okay, so for example, if I had a picture like this, so I'm just going to show you a different example so you see what symmetric about the origin looks like. If I have a picture that looks like this, okay, symmetric about the origin means here's the origin. If I were to fold this and flip it across this point, it would go onto here. And I feel like some of you can't visualize it. Like some of you might be like, no, that doesn't make sense. And some of you might be like, yes, it does. So here's the trick. To see if something is symmetric about the origin, all you have to do, and I did it here because you're probably going to type it in, is if you flip your calculator upside down, do you see the same exact picture? That's what it means to be symmetric about the origin. So I'm going from left to right, down, and then up. So if I flip it, I'm going left to right, down, then up. Is it the same exact picture? Yes. So that means that this picture would have been odd. Okay. And that's how I know if something is even or odd. Now, how do you remember these rules and these tricks? The only way that I've memorized it in the past is I think, okay, odd starts with O, origin starts with O, so the O's go together. And then the other one just has to be the y-axis. That's how I memorized it, but you can memorize it however you want to. Hudson, do you have a question, comment, concern?
I was thinking earlier, was it, I had a thought, but I think it was wrong.
Okay.
Also, as, how is it? 1 second.
Okay, I'll come back to you. Yes, Tony.
When's the next song?
What?
When's the next song about an equation?
Oh,
yeah.
oh, it's coming up next chapter, the end of next chapter. I'm sorry. I know. Have you been anxiously waiting
Yeah.
and singing the old songs to yourself just to keep it company? That's okay. I understand. I do that too. Okay,
Just said he forgot that.
Tony, you are an embarrassment
We know.
to the math song world. You should feel ashamed. All right. Next thing that we're going to ask you is, okay, so now let's go ahead and tell me the vertex and tell me what the axis symmetry is. So last week we learned, oh, vertex and axis symmetry, negative b over 2a, and then plugging it back in the calculator to find the vertex. That takes so long. Well, remember, we learned a new form, how to write an equation in a different form. The reason why we want to know this form is because then it gives us different pieces of information. I don't have to solve for anything because do you see how there's parentheses here that look like that? That means that they wrote this equation in vertex form. So let me just write vertex form above it so you can see. So vertex form is y equals a, parentheses, x minus h squared plus k. And remember how we said the vertex, if it's written in this form, is always going to be h comma k. So let's look for an h and let's look for the k to see what the vertex is. Because last week we actually had to solve it out. This week, because it's written in this specific form, I can just look at it and write it. Does anyone think they know what comma what would be the vertex? Sophia? 2 comma 0 is so close. Hudson? Yeah. So this is always the tricky part. So first of all, I see a 2, so I know it's some formation of a 2. And I see nothing here, that's why it's like a 0. Okay, so that was right. But the reason why it's -2, even though it says +2, which is super confusing, is you always have to think it's the opposite. Do you see how your original formula had a minus in there? Which means that if they don't have a minus, then it's not a +2. It's like they were writing x minus -2, and that's how they got +2, because minus negative is plus, right? And that's how you know that it's -2 and not +2. Okay? And then you want to find the axis of symmetry. So axis of symmetry is always an x equals. So what does your x equal? -2. So your axis of symmetry is -2. So do you see how finding those answers took you maybe a minute to do? Whereas last week, when we didn't teach you vertex form and we taught you standard form, it probably took you about 3 minutes to figure out both of these answers. Notice how there's also no work. There's no work to show because the answer is just in plain sight, right? It's in the equation. So if you know where to look for it, then you're good to go. Okay, backside. This is going to be the hardest part of this lesson and the level work, okay? So for number 3, backside, it says, write an equation or write a quadratic function in vertex form whose graph has the given vertex and it passes through the given point. So it's telling me, here's this information and I have to write this in vertex form. So vertex form is, let's write it first, y equals a parentheses x minus h squared plus k. By the way, this is not something you need to memorize. Vertex form is at the very bottom of your star chart. It is right there. What?
Song.
Oh, there is no song. Sorry.
You can just make one.
Fine.
I love it.
Vertex form is the following. Y equals a parentheses x minus h. Don't forget to square it and add the k. Tony, this song is for you. If you don't like it, I don't care. This is the vertex form formula. Yes.
I'd like to reinform you are still recording.
Oh, darn it! Darn it! Tony, see what you do? It's all your fault. It's always your fault, Tony. Yes, Lincoln.
I'd like to inform you that that was actually better than the other songs.
You
Just
suck.
for making that.
All right, all of you suck. All right, anyways, let's move on.
Garbage, but that one was
Okay.
good.
So I have this information. I need to somehow write it in vertex form. So they give me a lot of information here. Remember, vertex is always h comma k. So I can substitute h and k for those 2 letters in my formula. If they tell me that it passes through a point, my point is always, what are the 2 letters when they give me a point? X and Y, right? So whenever people give you a point, they're just not giving it to you because they want you to know something random. It's because they want you to use it as an X and a Y. So I'm going to substitute it in. So Y, I see a 7. So 7 equals A. I don't know A, so I'm leaving it as A. Parentheses. X, it says is -7 minus H. H is -4. So notice how I wrote 7 minus -4, not -7 minus 4. Squared plus K, and it looks like K is -2. Okay. Now it looks like we have one variable, one letter, so let's solve for it. So I have 7 equals A parentheses, -7 minus -4. Gosh, it is Monday and I don't know. So why don't you just use your calculator just because there's so many negatives going on? Oh, it's -3. Okay. So A parentheses, -3 squared, and then plus -2 is just -2. Okay, so let's simplify that. So I have 7 equals -3 squared, because PEMDAS tells you to do exponents first. -3 squared, is that -9 or +9? +9 because of the parentheses, right? So don't forget there are parentheses there. -3 times -3 is +9a, and then -2. So now this has become a two-step equation. So what's the first thing I need to do to solve this? Add what? Add 2 to both sides, right? This is a two-step equation. Always do your adding and subtracting first. So I have 9 equals 9a. Divide by 9 on both sides because you want a by itself. So you have a equals 1. Oh, okay. All of that work just for a measly 1. Well, now you have your final answer, right? Your final answer is in vertex form. It's y equals a, which is 1, parentheses, x minus h, which they told me was -4, squared plus k, which they told me was -2. But of course, the minus -4 changes to a plus. Yes, Tony?
If one is measly, then why is it first place?
What?
If one is measly, then why is it first place?
What do you mean, why is it first place?
Like
Number
first
one
place,
is-
second place, third place.
Oh,
First place is the one.
I don't know. Why are you asking me these questions?
Are you saying
But you said
people
one
in
is
first?
measly, so then his first place is measly.
Well, I mean, like, you know, it's like a teeny tiny one. At least, like, if you're going to solve something big, give me a big fat number as an answer. I don't know. Okay.
But if
Anyway.
someone's 1 foot tall when they're born, that's not measly. That is tall.
That is pretty tall. What?
Yes, you are right,
No,
I
wait,
suppose.
1 foot tall would still be short.
If you're born a foot tall, that's a no.
Most children, most babies are like 20-ish inches when they are born. So they're over a foot tall.
Never mind.
So if you are under a foot tall when you were born, then you might have been premature, and that's not a good thing.
I was thinking of a young one.
Hey, I was a big fat baby.
Okay.
I was a chubby.
Level
Unless
work.
your brother had a heck ton of hair.
All right. I'm just going to talk through your level work with you just so you know, like, this is not anything new. So guys, for numbers 1, 2, 3, 4, and 5, is it even, odd, or neither? That's exactly what we just did right here. Okay, so just tell me, what does it look like? Put it in your calculator. Showing your work just means giving me like a quick sketch of the graph. That's it. 4 and 5, I don't have to show any work because they gave me the graph, right? So that's how I would show my work for numbers 1, 2, and 3. If you don't want to do it the math way. If you want to do the math way, great. Show me the math work. Okay. 6 through 11, find the vertex and the axis of symmetry. They're writing everything in vertex form, so there's no work to show. It literally is just like number 2. There is no work to show for number 6 through 11. Even if you wanted to show work, I have no idea what you would show. Okay, it shouldn't take you very long to do each of these, maybe like under a minute each, because you're just looking at it, writing it, looking at, writing it. Okay, 12, 13, 14, and 15, you're graphing it. And then you're gonna write, like you're gonna compare it. So let's just do number 12 together. Okay, so the first thing it says to do is graph it. Sure, you can put this in your y equals, you can go to your table and graph it. Or you can take half of that amount of time and just do it by hand. So remember, the reason why doing it by hand is easier is because all the information is already given to you. Look, h comma k is your vertex. So my vertex is what comma what? -2. Good job. It's -2 comma 0, which is right here. Do you remember how we said the first number always shows you the stretching and the shrinking? So that's how much you're doing here. You're going 4. So you're going over 1, up 4, over 1, up 4, and then boom, that's your picture. Right? You can just do it by hand still. So like this one, you're going over 1, up a third of a square, over 1, going up a third of a square. But you could just put it in your calculator if you're the least bit unsure and go to the table too. Yes, Andrew? Is there any what? No, there's no work to show for 12 through 15. Okay, but it does say compare. So there's 2 things I need to write. Okay, the first thing I need to write is, well, I mean, your vertex did change, right? It went from there, parent function, to there. Okay, so I would say you had a translation. How many spaces? 2 to the left. So that's the first thing I would have to write. And then there was stretching and shrinking. So look at the number. It's 4. Is it a stretch or a shrink? Stretch. Why is it a stretch?
Bigger than 1.
Because it's bigger than 1. So it's a vertical stretch of 4. Remember, if it's bigger than 1, it's a stretch. If it's a number between 0 and 1, like this one, it would be a shrink of a third because it's between 0 and 1. And boom, you're done. So that shouldn't take you very long to graph by hand, or just put it in your calculator as well. Okay, number 16 and 17 are the biggies. So let's do number 17 together. That's actually the harder one, okay? So number 16 and 17 actually is the backside of your starter. It is literally the same exact thing. The only thing different is for number 16 and 17, after you write your final answer like this, they ask you to then rewrite it in standard form. And it's not that hard, but we all make the same mistakes. So I want to make sure we do this one together so it's not too difficult. Okay, you have to write small, okay? Because you're going to need a lot of room. You're probably going to need all that space. Okay. So write it in vertex form. Vertex form is y equals a parentheses x minus h squared plus k. And remember how they told us the vertex is always h comma k. And then the point they give me is always x comma y. Okay. Online kids, I haven't heard from you all period. You might think that we are crazy, right? Or just Tony is crazy. So online kids, you're up. Can someone unmute themselves or type in? What number am I writing for y? Online kids, this is you.
0.
Thank you. Do you see how y right here says 0? So you're doing 0 equals somebody else online. Oh, wait, hold on. Not yet. A. I don't know A, so write A. I'm going to write this in purple. It's darker. Parentheses. Okay, somebody else online. X. What number is X? Somebody online?
7.
Thank you. 7 minus somebody else online. What do I write for H?
5.
Thank you. And then squared plus somebody else online. What do I write for K?
-2.
Thank you. Okay, so now let's simplify it. So I have 0 equals A times, okay, 7 minus 5 is 2. You can do that in your head. 2 squared is, what is 2 squared, guys?
4.
4. So I have 4A. Do you see how that just becomes 4A? 7 minus 5 is 2. 2 squared is 4. So 4A plus -2 is just -2. Okay, so now it looks like I'm going to add 2 to both sides. So I get 2 equals 4A. Then I'm going to divide by 4 on both sides. So I get 0.5. A is 0.5, or I get A is half. I don't know. Do you want to write it as a fraction or decimal? Decimal, sure. Actually, no, fraction would be easier because normally when we write equations, having it in fraction is easier. But you can have decimal, it's fine. Okay, so your final vertex form answer is y equals A, which is 1/2, parentheses, x minus h, h is 5, squared plus k, which is just -2. So that's your first answer. That was exactly like the starter. Hopefully that's not too difficult. Yes, Sophia.
But if they did like X, oh no, they only did.
Are you sure?
That's my own question.
Okay. So I need much more room, so I'm going to transfer it over here because that's not nearly enough room. I need almost the whole amount of space. I do. Okay. Now it's telling me to change this to standard form. So this is what kids do wrong, because I'm basically telling you multiply it all out, combine your like terms. The first thing kids do wrong is they're like, oh, PEMDAS. Okay, PEMDAS tells me to do exponents first, like out of what I see here. Exponents means to do that. Can I just take this 2 and square it to be x squared minus 25? No. Remember we said that was not okay. What did I have to do instead?
Have to separate it out. Separate it out.
Yeah, separate it out, write it out, and then FOIL it or distribute that. Remember last chapter? Okay, so that's the first thing that kids make a mistake with. The second thing that kids make a mistake with, they're like, oh, I see parentheses, I have to distribute. So really it's like 1/2 x minus 2.5 squared. That's not the case. I'm not foiling this, I'm foiling this, okay? The reason why I can't distribute yet is because PEMDAS tells me to exponent first, then multiply. So what the class said to do was write out x minus 5, separately, you can't just like swoop, swoop, like that and just square everything. That doesn't work. And then first, outer, inner, last, or you can distribute it. So you end up getting y equals 1/2 parentheses. Don't forget the parentheses are still there because you're still multiplying it by 1/2 later. X squared minus 5x minus 5x plus 25, because I just distributed it, or I just FOILed it, minus 2. Now remember the last step of FOILing was combining your like terms. So really I have y equals 1/2 x squared minus 10x plus 25 minus 2. Okay, now I distribute. So I have y equals 1/2 x squared minus, what is half of 10? 5x plus half of 25 is 12.5. Don't forget, you still have the minus 2 there. Okay, almost done. So let's just combine these like terms, right? So don't you just have y equals 1/2 x squared minus 5x plus 10.5, because 12.5 minus 2 is just 10.5. Oh, that was it. That's how I changed from vertex form to standard form. You did that in your video notes, but since it was 3 days ago, I'm afraid you forgot.
I did my videos last night.
Oh, well then there you go. Nothing like some procrastination, bad boy.